Greetings, this is M squared, and we're going to solve some linear systems using substitution. Let me just remind you that there are three things that can happen when you solve systems of linear equations. When there are two lines, they can intersect and have one point of intersection, which is the solution. They can be the same line and intersect in all points, or they can be parallel lines and not intersect at all. And we in the book, they call that consistent and independent when you have one solution, consistent and dependent when there are many solutions. So remember that word consistent means you actually have a solution. Inconsistent means you do not have a solution. So there's one solution, infinite amount of solutions, that's the consistent part. Independent means they're two different lines, dependent, the same line. And then inconsistent means they're parallel lines and you have no solution. So keep those in mind because the book might ask you, about those things, these three things. Or they might just ask you to find the answers. So either way, you need to know which one. Okay, we're going to use substitution. The time that you want to use substitution is when one of the variables is all alone. If you have to use substitution and a variable isn't alone, then you just get it alone. So what we notice here is that n is all alone and n equals 3 minus 8m. What that means is in this equation, anytime I see n, I can make the substitution of what n is equal to. So I could take the n out and put what it equals. So what I like to do is write down the equation, but not n. So I didn't write n down, and now I'm going to make a substitution. I'm going to put in for n what n is. So n is 3 minus 8m, and then I'm going to simplify. So 5m plus, I'm going to distribute, so 2 times 3 is 6, 2 times negative 8m is negative 16m, equals negative 27. The whole reason we do this is to get one equation with just one variable, because then I can solve for m and figure out what m is, and then m helps me to figure out what n is. So combining like terms, 4m minus 16m is negative 11m, plus 6 equals negative 27. If I minus 6 from both sides to try to get m alone, I get negative 11m equals positive 21. And oops, I made a mistake there, didn't I? That was supposed to be a negative, so let's go back. Then that would be negative 33. Okay, moving right along to get m alone, we're going to divide. Since it's being multiplied by negative 11, we divide by negative 11 to get rid of the negative 11 and get m alone. And we find out that m equals a negative divided by a negative is positive, and 33 divided by 11 is 3. Once I have m, I substitute again. I put my m back in there, in for n. So I get n equals 3 minus 8 times 3. Well, 8 times 3 is 24, so now I get 3 minus 24. 3 minus 24 is negative 21. So that's my n. And now this is the important part. You want to check. I'm going to check m and n into this equation. I always like to do it on the calculator. So what I'm going to do is I'm going to rewrite this equation. And I like this calculator because you can see the whole equation or expression that you put in. So I'm going to put 5, and in parentheses instead of m, I'm going to put what I found m to equal, which is 3. Then plus 2 times, and n was negative 21. So I'm going to put that there, and I'm going to press equals, and if I get a negative 27, I'm right. If I don't, I did something wrong. I got it right, so I know I have this problem correct. And I only checked that second equation because I actually put the 3 into this first expression and got the negative 21. So if I didn't make a mistake doing that, then I know I got that right. And the reason I know I didn't make a mistake is because this second one was correct. So whichever one I substitute in, I let that be the check for that one, and then I substitute both of them in the other equation. All right, let's try this one. The y is alone, so it's easiest to substitute in this 4x minus 3 and for this y. So I put that right in there. So I rewrite the expression, but I leave a space for y, just like I did on the other one, and in for that, I'm going to put 4x minus 3. And then I'm going to simplify. 4x times 2 is 8x. 2 times negative 3 is 6, minus 8x equals negative 8. These are like terms. 8x minus 8x is 0. 0 minus 6 is negative 6. Does negative 6 equal negative 8? No. My x's canceled out, and I get negative 6 equals negative 8. That is impossible. It is not true. It's inconsistent. So that's how I know that the lines are parallel. When the x's cancel out and I get things that are not equal, I know my lines are parallel, so I know that there are no solutions. Now, what this one looks like, because we kind of did these two, this one, the x's would still have canceled out, but I would have gotten something like 5 equals 5 or 0 equals 0. It would have been true. When it's not true, that's how I know it's a no solution. So that's how you use substitution to solve linear systems. And if this was like an x and a y, if that was x and that was y, just so you know, a lot of times they're going to want it in that kind of form, in point form, the solution to it. But this is fine usually when you don't have an x and a y. And good luck solving by substitution. And this is m squared, signing out.